Now we go for chapter number 8, which is about binomial theorem. Very small but important chapter, remember. So you know bi means 2. So we'll here expand in general an expression involving two terms. You know, if you have a plus b the whole square, you can expand like this: a square plus 2ab plus b square. That you know very well, right? If I have a plus b the whole cube, that also you know how to expand. A cube plus, here I can write 3a square b plus 3ab square plus b cube. That also we know very well as a formula. But if you have in general, your question is, if you have a plus b the whole raised to n, where n is any positive integer, how to expand this? That's the question, where n can be 4, 5, 10, 100 and so on, remember. So let's observe this. Here you see coefficient of a square is 1, which I can write 2c0. What is 2c0? It is 1 into a square. Here coefficient is 2, which I can write 2c1. What is 2c1? 2 into ab. Plus here coefficient is 1 again, which I can write 2c2 into b square. Fine. So what I did over here, I have expressed coefficient in terms of combination symbols, remember. 2c0, 2c1, 2c2. Why I have chosen 2 here? Because power is 2. Same way here, coefficient is 1. You can write here 3c0 into a cube. This you can write 3c1. 3c1 is 3. You can verify. Into a square b as it is. This I can write 3c2. You know 3c1 and 3c2 are equal and both are 3. Into ab square plus here coefficient of b cube is 1, which I can write 3c3 into b cube. So here coefficients have expressed in form of which symbol? NCR symbol. 3c0, 3c2, 3c3. This is just 1, 3, 3 and 3. So I'll generalize this concept. So I'll start with here, for any positive integer, remember, for any n belongs to n, for any positive integer, we are doing this, remember. So it starts with nc0. nc0 is 1, you know. Now you see, if you're raised to 3, it starts with a cube. If you're raised to 2, it starts with a raised to 2. So here obviously it will start with a raised to n. Plus, then what happens if you observe the second term? You see power of a is decreased by 1 and now power of b is 1 here. Power of b was 0 here. b raised to 0 you can write. So nc1, now next 0 then 1 into, you decrease the power of variable a, which is minus 1 into b raised to 1, that is just b. Now next nc2, power will decrease by 1, so here minus 2 into b square. If you want one more, you can write nc3 into a raised to n minus 3 into b cube, and so on. The last one, that is ncn, which will be 1. Now you see here power of a becomes 0 and minus 3 and so on. So which is 1 into, now in the last term, power of b will be n. So this expansion is called binomial theorem. This is called binomial theorem. Binomial theorem for expansion of two terms, remember, for positive index, for positive power, remember. Here power is positive. I repeat how I did this. For any two real numbers a and b raised to n, where n is positive integer, n is positive integer, remember. How do I expand this? It starts with this nc0 into a raised to n. highest power of n. If you have 3, you have started with a cube. See, you have a raised to n, a raised to n. Now very simple. You increase this 0, then 1, then 2 up to ncn. And you simultaneously decrease the power of a here, n minus 1. अब b का पावर 1 चालू हो गया, यहाँ पे b का पावर 0 था, remember. So a raised to n minus 1 into b. What about this? Here, power of a again decreased by 1. So a raised to n minus 2 b squared. And so on. The last one is a ncn b raised to n. Fine. Now here power of a becomes 0, remember. If you write the previous term, then it will be ncn minus 1 b raised to n minus 1 and a raised to 1. Every time you observe here, total power, total exponent of a and b, it would be n every time, if you just notice this. If you observe carefully each term here, right, the sum of powers of a and b, and here n, here n, here n, and here n, remember, right? That's one observation. Number one, it always starts with 0 and it ends when these two are equal. See, 3c0, we stop at 3c3. 2c0, we stop at 2c2, right? So this expansion, a plus b whole raised to n, written in this way, is called binomial theorem. This is known as which theorem? Binomial theorem. It can be proved also. How do we prove? Proof, you can, if you are interested, not important for us. Use what? Can you recall? When certain statement is defined for natural number, what should be used? PMI, principle of mathematical induction. It can be proved using PMI. It's not a big task. You can try if you are interested. It can be asked as an example, remember. Try yourselves. Okay. Now I want to know 2-3 things about binomial theorem. I hope this is clear to you what I'm trying to tell you. I'll repeat one more time. A plus b raised to is start with nc0, highest power of n. Then increase indices nc1, nc2 up to ncn. When we stop, if these two are equal. Decrease power of a, simultaneously increase the power of b. Here power of b is 0, remember. Here n minus 1, 1, n minus 2, 2, n minus 3, 3, and finally b raised to n. What's the power of a here? Here power of a is 0. No need to write. A raised to 0 is 1. What's the power of b here? 0. Right, which is 1. So we normally never write this. This is just 1. And this is also 1. We normally never write that, but just for your information I'm telling you. Fine. Now, if you have raised to 3, there are 4 terms. If you have raised to 2, there are 3 terms, because it starts with 0, goes to 2. Starts with 0, goes to 3. So if you have raised to n, how many terms are there? Not n terms, remember, n plus 1 terms. So let me write that. In the binomial expansion, so we note these 2-3 things. Number one, note in the expansion of a plus b whole raised to n has n plus 1 terms. Remember, there are how many terms? N plus 1 terms. If you are raised to 2, then 3 terms. If you are raised to 4, then 5 terms. That's one thing. Second thing, here sum of the powers means exponents of a and b in this expansion. A and b is small n, whatever that power. If this is 3, then there should be 3 in each term in the expansion, remember, each term in the expansion. That is another observation. Har ek term mein power will be that n only, remember. Okay, now you can write as a result. Let me write as a result here. I'll write as a result, one result. What I'll do, I'll just place put a equals to 1 and b equals to x in the a plus b whole raised to n equals to that expression. We are going to put this. So what we'll get here, this is just a special case of a binomial theorem. 1 plus x the whole raised to n equals to it starts from n say 0. Now a raised to n, a is 1 here, 1 raised to n is just 1, remember, plus nc1 a raised to, now n minus 1, a is 1, remember, but now here b is x, so b plus nc2 into x squared. B will increase, a is every time 1, just place the value you realize, right? Have a look into that, and so on. Finally ncn into x raised to n. This you can use directly, remember. Okay, for any positive integer, this just follows from binomial theorem. This just follows from where? Binomial theorem, remember. Just put a equals to 1 there. So here everywhere when I put 1, this become 1, this become 1, this become 1, and what is b? That is x. So x squared and x raised to n. Fine. So for example, if I want to expand this, 1 plus x whole raised to 4, so I can write like this: 4c0 plus 4c1 into x plus 4c2 into x squared plus 4c3 into x cube plus 4c4 into x raised to here 4. We stop now when these two indices are equal. Okay, so what is 4c0? It is always 1. What's 4c1? It is 4, right? You know it, previous chapter. 4c1 is 4 into x. What is 4c2? How do we write it? You can do this much of 4 factorial upon 2 factorial into 2 factorial. You know this formula. So here 4 into 3, 1, 2 factorial will cancel. 4 into 3, 12 by 2. So this is just 6x squared. You know 4c3 is same as 4c1 and 4c1 is 4. So this is just 4 into x cube. What is 4c4? When these two are equal, this is always 1 into x raised to 4. So this way we can expand 1 plus x the whole raised to 4. This is because of binomial theorem, remember. Fine. Here you see this coefficient, these are called coefficients: 1, 4, 6, then they decrease, this 4, 1. First and last are always equal, then these and these are always equal. You know this in binomial theorem. Even these and these are always equal. First and last are equal, middle are always equal. Okay, fine. Now we want to write the same result but for minus sign. Now let me write result number 2. One more result here. That's just based on previous only. One more result. That is, put a equals to 1 and b equals to minus x. Where in the binomial theorem. In the binomial theorem. Fine. So what we'll get here on the left hand side? On the left hand side you will get here 1 minus x the whole raised to n, where n is positive integer, remember. It should not be fractional value. So there nc0, now because of this minus we have minus here, nc1 into x plus nc2 into, because of this even power this is plus, because this is even power. Here because of the odd power it will come plus, here it will be minus now, alternative sign, nc3 into x cube, and so on. Finally at the last you have minus 1 raised to n, that depends upon n, ncn into x raised to n. That last term is not important, you can write dot 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 also. For example, if I want to do 1 minus x the whole raised to, let me write 3. So I can write 3c0, you can expand directly also. Then you have minus sign here, 3c1 into x plus here 3c2 into x squared minus 3c3 into x cube. There are 4 terms on the right hand side, 3. Now what is 3c0? It is 1. What is 3c1? You know it is 3x. 3c2 is same as 3c1. You know these two are always equal. So plus x square. 3c3 is same as 3c0 and which is 1. So x cube. This expansion, you know it. 1 minus x the whole cube. Fine. Okay. Now one more result here. So result number 3 here. Third result. Let me write the third result. What we are going to do is, in the binomial theorem, we just put a b equals to 1. So put a equals to 1 and b equals to 1. A, b are equal and 1 in where a plus b the whole raised to n in this expansion. So what we'll get? Left hand side is obviously it becomes 2. If I put a, b equals to 1, what is left hand side? Here it will be just 2. 1 plus 1 the whole raised to n. So it will be just 2. So 2 raised to n equals to, here you have nc0, this is 1, nc1, both are 1, plus nc2, and so on, finally ncn. Right? So this summation is always 2 raised to n. Very important expression, remember. I forgot to mention in the beginning that this nc0, nc1, these are called binomial coefficients, remember. So I'll write here this nc0, you can write there in the beginning below this theorem, nc0, nc1, nc2, and so on, ncn, these are n plus 1, are called, in general we call this 1, 2, 1 and n coefficients. Here these are called binomial coefficients. Binomial coefficients. These are called binomial coefficients. These constants nc0, nc1, nc2, ncn, these are known as what? Binomial coefficients, remember. These are called nc0, nc1, nc2 and so on, ncn are called the binomial coefficients. So in this result number 3, what I'm trying to tell you is sum of the binomial coefficients is always 2 raised to n. Sum of binomial coefficients is nothing but, what is that? 2 raised to n. Right? So here, if I want to answer this, for example, 4c0 plus 4c1 plus 4c2 plus 4c3 plus 4c4, when these two are equal, we'll stop. Now one way is you find 4c0, you find 4c1, you find 4c2, 4c3, 4c4, and you add them. That's one way. What's another way? 2 raised to n. This n. So here what is the answer? 2 raised to 4. What's 2 raised to 4? You know, 16. That's your answer, remember. Okay, you can directly verify if you want. Let me verify here. No need to do, but just for your information. What's 4c0? It is 1. What is 4c1? It is always 4. What's 4c2? You know how to do this. 4 into 3. 2 factorial will it cancel by 2. So what is this? 12 by 2. So 6. What's 4c3? Now you just need to reverse. 4c3 is same as 4c1 and which is just 4. 4c4 is same as 4c0 and which is again 1. Check this. 6 plus 4, 10 plus 14 plus 2. You are getting 16. Right? Here you could do directly by this result. Sum of all binomial coefficients is always 2 raised to n. I repeat. Sum of all binomial coefficients is 2 raised to n, remember. If I ask you one more thing, this was first example. Suppose I want to get this. One more example. Let's write 5c1 plus 5c2 plus 5c3, 5c4 plus 5c5. What is the value of this? That's the question. Right. So one way answer this. What's one way? You find the value of each of these and you add them. The another way is, that if it starts with 5C0, then this is 2 raised to 5. Is it? If it starts with 0 up to this 2 equal number, then it is 2 raised to n. But यहाँ पे 0 term नहीं है. So you consider there is a 0 term here. So what will be your answer here? 2 raised to 5. यहाँ पे 0 term है, इसको इस साइड ले लो तो minus 5C0. It is 1. 2 raised to 5, 32 minus 1. So your answer is 31. That way also you can answer. Okay. So we have 3 important results here. The first result is about expansion of 1 plus x the whole raised to n, right? As I explained, that's result number 1. Result number 2 is about expansion of 1 minus x the whole raised to n, right? Just alternative sign. Result number 3, that's about what sum of all the binomial coefficients is 2 raised to n. One more thing here, let me write that as the result number 4. So let's write result number 4 here. This follows from where? Binomial theorem only. So we put a equals to 1 and b equals to minus 1 in the expansion of binomial theorem, in the binomial theorem. Let me put this. So what we'll get? Obviously left hand side will be 0, right? So this would be obviously 0. So 0 equals to, this is 1, so n says 0. Now this is 1, but here you have minus 1, so this will be minus nc1. This is 1, but even if you write minus 1 whole square, it will be plus 1, so nc2. Now next will be obviously alternative sign, my nc3 plus nc4 and so on. So what you have noticed here, if I take all the terms having this odd indices on the other side, then both will be equal. What I'm trying to tell you is here, you can write like this. You see nc0 plus nc2 plus nc4 one side and all minus terms on the other side. That is what nc1 plus nc3 odd indices plus nc5 and so on. These two are always equal. In combination symbols, if you have even index here 0, 2, 4, this summation is always equals to odd. And I leave it to you. It can be proved that the value of each of this as well as this, each has value equals to 2 raised to n minus 1. Try to prove this. This is for you. Exercise for you. इसका आप summation करो तो इसका answer 2 raised to n minus 1 ही आएगा. If you add all this, you'll get the answer 2 raised to n minus 1 only. Try. This is for you. Okay, so 4 results we have. All these results follows from where? Binomial theorem only. Fine. Okay. Now here, let's try one more thing. If I have a plus b the whole raised to 0, it means it is just 1. Fine. If I have a plus b the whole raised to 1, what are the coefficients? 1 and 1. Coefficients 1 and 1. If I write a plus b whole square, what are the coefficients? Your coefficients. What are the coefficients here? 1, 2, 1. So 1, you add this to 2 and then here 1. If I write a plus b whole cube, you will notice that the coefficients are here. Expand a plus b whole cube, will realize coefficients are 1, then sum of these 2, 3, sum of these 2, 3, and here this 1. So this is like a triangle. You see, this is just nc0. What is this? nc1, sorry, nc0, nc1. N means here 1, remember. and here 1. What about this? Here this is nothing but the 2c0, this is 2c2, this is 2c1, this is 2c2. This is nothing but here 3c0, here this is 3c0, 3c1, 3c2 and 3c3, remember. So if you want to write next, here you write the sum of these two, which is 4. Write the sum of these two, which is 6. Write the sum of these two, 4. And then again you put 1, 1 at the end. So you'll get a triangle like this. These are nothing but the coefficients of what? A plus b the whole raised to n in general. In the first line, coefficient of raised to 0. In the second line, coefficient of raised to 1. Third line, coefficient of raised to 2. Then coefficient of raised to 3. Here these are the coefficients of what? A plus b the whole raised to what? Here 4. If you expand this, you will get these coefficients. So you will get a triangle like this, and this is sometimes called, you might be knowing, this is called Pascal's triangle. This is just for your information. Refer the textbook, you will realize. This is known as which triangle? Sometimes Pascal triangle. Pascal triangle gives us the coefficients in the expansion of, in general, a plus b raised to n, remember. In the Pascal triangle, we'll get the coefficients of a plus b the whole raised to n. Okay, so now we go to probably next exercise. That's the first exercise of this chapter, which is exercise 8.1 here. First question, in exercises 1 to 5 you are going to expand. So here 1 minus 2x the whole raised to 5, right? So here this is like a here, a is 1 and b is minus 2x, right? And we expand by binomial theorem, right? Binomial theorem. So this is equals to here, this is equals to, it starts from where? 5c0 into a raised to n, that's 1 raised to 5, which you can drop if you want. 5c1, now 1. Now reduce the power of 1, which is raised to 4, and b with minus n, remember, minus 2x raised to now 1. Total power should be this index, plus 5c2, 1 raised to 4, no, 1 raised to 3, into minus 2x the whole square. Then one more term, let me write 5c3 here, 1 raised to 2, and minus 2x the whole raised to, here now we are going to increase 3, plus here 5c4, 1 raised to 1 minus 2x raised to 4. Here it was 3, now it is 4. And last term 5c5. Now we are going to stop. 1 raised to 0, which I am not writing here, minus 2x raised to 5. This is what the binomial theorem, remember. This is a binomial theorem. Now we just simplify. You cannot live like this. Obviously you need to simplify. Okay, what's 5c0? It is 1. Here 5c1, it is 5. Into, this is minus 2x. Let me keep right now as it is. What is 5c2? If you want, you can write here only 5 into 4. Upon you have 3 factorial. That will get cancelled by 2. Into, this is nothing but the 4x square. The value of this. Plus, अब जानते 5c2 is same as 5c3. So a value ही होगा. This much only, remember. What is that? 5 into 4 by 2. This is nothing but the minus 8x cube. Minus 8x cube. Plus 5c4 is same as 5c1. So it will be just 5. This is even power, so 2 raised to 4 16 into x raised to 4. 5c5 is same as 5c0 and which is 1 here. And here your odd power, so minus 32 into x raised to 5. So if I write last step finally, here, what will be my last step? This is 1, this is minus 10x. You know this is 10 into 4 here, so 40x squared. What about this 10 into minus 8, so minus 80x cube. This is again, 80 into x raised to 4. And finally, here last term is minus 32 into x raised to 5. Right? You need to be little careful when you do the simplification. There should not be any algebraic mistake, remember. I hope the first step is clear to you. This is just binomial theorem. Then this is just a simplification, remember. Fine. So this gives us expansion of which expression? 1 minus 2x raised to 5. Now for any positive power you can expand after doing this exercise, remember. Okay. So next question. What about next question? Let's do that. Here. Question number 2, second question. You have 2 by x minus x by 2 the whole raised to 5. So you will be having how many terms on the right hand side? 6 terms. Remember, how many terms? 6. 5 plus 1. So let me expand this. Here it starts with 5c0 2 by x the whole raised to 5 a raised to n plus here 5c1 decrease the power of this one by 1 and simultaneously increase, but minus sign should be taken with this, remember, don't make the mistake. X by 2 the whole raised to 1 plus 5c2. Now you decrease the power of the first term, 2 by x raised to 3, and you are going to increase here x minus x by 2 raised to 2. Every time power should be this number. Plus here 5c3 into 2 by x. Here now we are going to decrease raised to 2 into minus x by 2 the whole raised to 3. 5c4 2 by x raised to here 1 and minus x by 2 the whole raised to 4. And finally last term 5c5, here power will be 0, so minus x by 2 the whole raised to 5. Right? Power of this one is 0, here 5. So this is a binomial theorem. Now we just simplify. This is simple algebra, remember, not a big task for us. You need to see that there shouldn't be any calculative mistake. 5c0 is 1, 32 by x raised to 5. 2 raised to 5 is 32. 5c1, it is 5. What about this? Here, this is 16 and this is by 2. So it will be 8. And one power will get cancelled here. So this is nothing but here 8. This minus sign and here minus sign will be there. This is raised to 4 power. So upon x cube. Just have a look on it. 5c2 आप जानते हैं. How do we write 5c2? 5 into 4. 3 factorial will get cancelled by 2. So 5c4, that is nothing but 10. So I'll write 10 here directly. Right? 10. What about this? Here 2 cube, here 2 square. So there you are just left with 2. This is even power. Here so minus sign doesn't play any role. This is x squared, this is x cube. So you are just left with x plus. Now 5c3 is same as 5c2, which is 10. I'll write here. This is nothing but 2 raised to 2. This is 2 cube. So you are left with upon 2. Minus sign is there. Here square will get cancelled. So we'll get the minus x, remember. Cube and here square. 5c4 is same as 5c1. 5c1 is 5. So यहाँ पे होगा 5. Now here even power. So minus sign won't be there. Here raised to 4. Here just x. So you will get x cube here. and upon this is 2 raised to 4 and here 2, so 2 cube, which is 8. 5c5 it is just 1, you know, and you have minus sign, minus x raised to 5 by 2 raised to 5, which is, you know, 32. This is just simplification. So finally here the last step for us will be you will get 32 by x raised to 5. This minus sign will come out here. This is 40 by x cube plus what we'll get here, 20 by x. This is nothing but just minus 5x. This is nothing but a 5 by 8 x cube minus x raised to 5 by 32. This is the expansion. Right? Expansion of which expression? This one, remember. Expansion. I wrote everywhere equals to. You see? This equals to. So expansion of this equals to this. That way you need to do. Now, what about next? Next you have raised to 6. So you can again expand it. So one more for you. X plus 1 upon x raised to 6, question number 5. So by binomial theorem, here it starts with 6 c0, right, little big C, into x raised to 6, a raised to n, remember, 6c1 into decrease the power of this, which is 5, increase the power of now the other one, b. This is like b, this is like a, remember. 1. Total power should be 6 every time. Keep that much in your mind. 6c2. Now decrease the power of this 4. 1 by x raised to 2. Plus here 6c3. Now x cube into 1 by x the whole cube. Plus 6c, you know, 4, x raised to here 2 into 1 by x raised to 4, plus 6c5, here x, and you have 1 by x raised to 5. And the last term here, plus here 6c6, here x raised to 0, 1 by x raised to, you know, 6 here. Let me simplify a little bit for you. What is 6c0? You know it is 1. nc0 is 1 into x raised to 6 as it is. What is 6c1? You know 6. Here 5, here 1. So you will get x raised to 4 power. Plus, what is 6c2? Here 6c2, you can do this much in rough. You know 6 into 5 into 4 factorial, that will get cancelled with denominator upon 2. So 30 by 2, which is 15. Right? How I did this? I've dropped one step. Actually, it is 6 factorial upon 4 factorial into 2 factorial. But the 6 factorial, you can write 6 into 5 into 4 factorial. That will get cancelled. So you are left with 6 into 5 by 2. So I wrote 15 directly, remember. Then, what about this? This is value of 6c2. Here raised to 4, here upon x square. So you are left with x square, remember. Here. Plus, this x cube will get cancelled. So this is just 1. What 6c3? You can do 6 into 5 into 4. That 3 factorial will get cancelled. Upon 3 factorial, which is 6. So 6 5s are. Here you will get 20. Fine. Now just you need to write in the reverse order. You know 6c4, ab jante it is same as 6c2. What was 62? You know that it was 15. So here 15. Here by x raised to 4 into x square. So into 1 by x square. Plus 6c5 is same as 6c1, and which you know it is 6. Into here raised to 5, here 1. So into 1 by x raised to 4. Plus 6c1, you know it is just 1 upon 1 by x raised to 6. This is required expansion. Right. Okay. Now the next question, 6th, 7th, 8th and 9th, use the binomial theorem to evaluate this. So question number 6, evaluate this. This is the question. Evaluate the first one here, and the 6th question, that is 96 the whole cube. Now one easiest way is you can just multiply 96 3 times, but it is clearly written use binomial theorem, right? That's mentioned in the question. So what we do usually to make the calculation easier, the 96 we write as 100 minus 4 the whole cube, right? We bring close to 0. If it is like 101, then you would have written 100 plus 1, right? If it is 102, then you would have written 100 plus 2. That is question number 7 and 8. If it is 99, then you would have written 100 minus 1. We bring close to 0, you know this. Yes, now you expand as usual. This is 3C0 into 100 raised to 3 plus 3C1. Now this is a binomial theorem, remember. 3C1. Here you have 100 square into minus 4. Here b is minus 4, remember. Don't just write 4, otherwise it will be wrong. Plus 3C2 now into, decrease the power 1 into minus 4 raised to 2. Right? You are increasing power here 1, now 2. Plus, now finally the last term, let me write here, which is 3C3. This is 0, but here you have minus 4 the whole cube. Right? That's just expansion. The only important thing is 96 I have expressed as 100 minus 4. Now you need to simplify. 3C0 it is 1. Now 100 cube. That is just 1 followed by how many zeros? 6 zeros. That 3C1 आप जानते, it is 3. Right? Here 1 followed by how many zeros? 4 zeros, because you have squared, into minus 4. What is 3C2? 3C2 is 3C1, and which is 3. Right? This is 100 here, into minus 4 square, which is 16. What about this here? 3C3, that is just 1, and you have minus here 64. You simplify all this, so you will get the value of 96 the whole cube. So if you simplify, you will get 884736, just to verify. Fine. Now same way you can go for 7th, 8th and 9th, these 3 questions. Question number 7, 8th and 9th, these 3 questions you can do. How do you do 7th? 102 whole raised to 5. So you can write as 100 plus 2 and expand it as I did there. Next question, that's 101. 101 you can write as what? 100 plus 1 the whole raised to 4 and expand it. And 99 you can write 100 minus 1. So finished up to 9th question.